Ever wondered what it would be like to hear the sound of a black hole? NASA has got you covered. Here is a screaming black hole. Screaming. In space? I thought in space, no one can hear you scream. Well, let me explain. Using a telescope, NASA examined the movements of hot gas in a cluster of galaxies in 2002. Then they converted what they found into a sonification. The sound, how should I put it politely, wasn't appealing, but that's okay. After all, you're able to hear the noise hot gas produces in a cluster of galaxies 250 million light-years away. Hey, would you like to hear the sound gas produces right here on Earth? Never mind. Sound waves already existed over there in the gas cluster, so experts just rescaled them to the range of human hearing. This is how they converted the input coming from the telescope. The principle is universal. In our atmosphere, we can hear stuff because pressure waves move through a medium like liquid or gas. Sound waves in these galaxies can also move because they're surrounded by gas. What does it have to do with black holes? Well, the thing triggering those pressure waves in the cluster is a giant black hole. To be more precise, it's a supermassive black hole that weighs millions of times more than the sun. Experts still don't fully understand the relationship between supermassive black holes and the clusters surrounding them. They only know that these two evolve together. They're interrelated. The cluster feeds the black hole with new material and so on. And in return, the black hole heats the cluster. That's all we know. Now, this made me wonder how large the biggest black holes are. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. Naturally, the biggest ones fall into the category of supermassive. The largest black hole in the universe we've discovered so far is about 66 billion times larger than the sun. It's one of the brightest objects in the universe. Astronomers keep scanning space and finding new black holes. But have you wondered when the first black hole was spotted? It was discovered by different researchers independently in 1971. Scientists first confirmed that these objects were formed from the remnants of massive stars. After a black hole appeared, it then consumed all the nearby objects. Here is a quick recap of how these space objects work. Their gravitational force is super strong. Nothing can escape a black hole after crossing the event horizon. Black holes eat everything, just like me. I mean, even light gets trapped inside them. What's even cooler, scarier, is that the laws of time and space become distorted there. If you were falling into a black hole, you would realize that time slows down there. Einstein explains this in his famous general relativity theory. In very, very basic terms, time gets affected by how fast you are moving at extreme speeds. NASA has discovered a rapidly growing black hole, but don't worry, the world isn't in danger. This black hole has been in front of the eyes of astronomers this whole time. It's in a region of a well-studied sky field. Astronomers say that this hole formed 750 million years after the Big Bang. You know, the birth of our universe. So why are black holes so bright? Well, that's a bit ironic. When I defined this space phenomenon, I said that black holes were so dense that even light got trapped there. But ask any astrophysicist, and they'll confirm that black holes are among the brightest objects in space. That's because black holes don't exist alone. They sit at the centers of galaxies and are usually surrounded by clouds of hot gas. And these clouds create cosmic auras around black holes. I must mention though, that you can't see a black hole directly. What you see is actually the effects it has on its environment. For instance, you can see space objects being ripped apart by a black hole. Remember when the first time ever silhouette image of a black hole was shared with the public in 2019? Proof, you fellas. You wouldn't really see the black hole if there was no orange ring. Why is the ring orange and not green or purple? The dark circle inside is the shadow of the black hole. The glowing orange of the bright ring in the image isn't the real hue of the gas. I'm a little heartbroken here. It's a representation picked by researchers to depict the brightness of the emissions. A scientist explained that yellow is the most intense emission, red is less intense, and black has little or no emission at all. In the optical range, this ring would likely seem white, perhaps tinged with blue or red. Spaghettification is a real word. That's an astonishing ability black holes have. If a giraffe fell into a black hole, it would stretch into a long, spaghetti-like strand. On Earth, the giraffe's legs are closer to the center of Earth, so they're more powerfully attracted to the surface than the animal's head. This rule works in the animal's favor on Earth, but would work against it inside a black hole. In a black hole, there's extreme gravity. The closer the giraffe's legs got to the center of the black hole, the more the pull of gravity would stretch them, and the closer to the center the giraffe got, the faster its legs would move. But the top half of the giraffe's body would be farther away, so it wouldn't move toward the center as fast as the legs. Here comes the spaghettification. Can we have meatballs with that? No? The only difference between a black hole and our sun is that the center of the hole is made of super dense material. It provides the black hole with a strong gravitational field that can trap everything, including light. This is why we can't see black holes. Did you know that theoretically, you could turn anything into a black hole? For instance, if you shrank the sun to approximately 4 miles across, you would compress the matter inside to an extremely small size. This would make it so dense that our star would turn into a black hole. You could do the same with a planet or even your own body. Is there something called a white hole, or is it just a myth? White holes exist in theory. Hypothetically, they function in the opposite way to black holes. Nothing can enter them. Physicists think of black and white holes as yin and yang, or two sides of the same coin. For them, a white hole looks exactly like a black hole, which makes different things come out of it. But the existence of white holes hasn't been proved yet. And how about wormholes? There are so many movies about black holes and wormholes. How many of them are based on reality? And how much is fiction? Some people believe that black holes function like wormholes. You go inside and exit in another part of the universe. Since we still have a lot to learn and discover about physics, no one can prove this theory is wrong or right. Astrophysics says we need to have a solid theory that unifies general relativity with quantum mechanics. Black holes are among the largest structures in the universe, but there might be tiny specimens. The mass of the smallest black hole we know about is only 3 times greater than that of our sun. Apparently, black holes can vanish. Stephen Hawking developed a theory of Hawking radiation. According to it, radiation decreases the mass and rotational energy of black holes, and ultimately, they evaporate. This process occurs very slowly, though, if we're not talking about small black holes. Astronomers have discovered an elusive black hole in the neighboring galaxy. What makes this one special is the fact that it's the first dormant stellar black hole outside of our galaxy. This type of black hole is hard to observe because such holes don't interact much with their environment. They don't emit as much radiation as other black holes. Back here on Earth, what about sinkholes? Well, different physics. Yet, if you cross the event horizon, your whole car can disappear. Whoops. In space, no one can hear you scream. We know that no supernovas, crashing asteroids, and burning planets make a sound in space. Or do they? What if you actually can hear something out there? Well, let's see. Okie dokie, back to middle school. Sound is a mechanical wave originating from vibration. What exactly does that mean? The simplest example is guitar strings. Let's pull one of them. It starts to vibrate. The atoms inside the metal string begin to push and beat the atoms of the air around them. So now, atoms are constantly pushing each other until they reach our ears. It's like a wave from a pebble thrown into a pond, and it happens very quickly, at a speed of about 0.21 mises. Then our eardrums begin to vibrate at the same frequency, and little bones inside our ears transmit this vibration to the brain. The brain then does its magic, recognizes the pattern, and turns it into sounds. Great! Now we know that we need some particles to create sound, and we can find these particles in gases, liquids, and solid substances. And what about space? Nope. It's an almost perfect vacuum, and you've probably already heard that there's no sound in space because it's a vacuum. But what does it actually mean? A vacuum is a perfect void. It's an area completely devoid of matter. It means there's nothing there. Yeah, despite all those celestial bodies in space, there's actually no air between them, no atoms or particles, nothing at all. Well, almost. To be honest, the perfect vacuum doesn't really exist. We can't get rid of atoms for good. But space is very close to this notion. On average, there are 15 or 80 atoms per 1 cubic inch. This may sound like a big number, but keep in mind that these atoms are tiny, and the void distance between them is huge. For comparison, 1 cubic inch of air contains about 16,000 atoms. So of course, with such a low density, these atoms can't push each other, even if the vibration is very strong, like, I don't know, a supernova. They still won't be able to do that. Oh no, movies have been lying to us. All these epic space scenes actually take place in an awkward silence. Who would have guessed? But don't get upset. What if I tell you that there are, in fact, some ways to hear sound in space? First of all, there's still sound on other planets. If there's an atmosphere on a space body, or at least something like gas, water, or a solid surface, there will be sound. In our case, the atmosphere becomes completely silent at about 60 miles above Earth's surface. That's where the sky stops being blue and a black starry veil begins. In any case, we'd have to land on another planet or at least get close to its atmosphere to hear something. But whatever it is, it'd sound very different. Let's take our favorite Venus as an example. The atmosphere there is very dense. Scientists jokingly call it thick chemical soup. So if you somehow managed to stay alive and speak there, your voice would be very different. It'd become much louder and it'd sound deeper. So if you want a pleasant baritone, you know what to do. I wonder what would happen if Earth had a denser atmosphere. What would we hear then? Well, you can vaguely imagine that if you've ever been in the water. Water is very dense. Sound moves there much faster and better compared to the air, at a speed of almost a mile per second. If you sit in an empty room with no sound sources, you won't hear much, right? Now, dip your head in the water and check out how the same silence sounds here. It's not quiet at all. Even if you ignore the ever-present sounds of the water itself, you'll immediately notice how well you can hear your own body, how your blood pulsates in the veins, how the heart beats, the slightest movement of your fingers. Kinda creepy, isn't it? This gives us an idea of what would happen to us on a planet with a denser atmosphere. And that's just crazy. We would hear everything, from scurrying animals to the movement of tectonic plates. Oh, come on, you'd probably say. It's obvious that there's sound on other planets, but didn't you say that we can hear something in open space? Actually, yes. For example, in a cloud of dust. You can find space dust almost everywhere in space. It may be the remains of a star or something else, and in these places, everything is a bit denser than usual. This means there are probably dust clouds where particles are very close to each other, which means they can produce sounds. Of course, those will be very quiet and transmitted over a very short distance. But it's better than nothing, right? Plus, we already have one real space sound recorded. It came from the Perseus galaxy, which is located 250 million light years away from us. NASA recorded it in 2003. Those of us music geeks will want to know that it's a B-flat, 57 octaves below C on the piano. You'd have to add another 6,600 keys to the left on the keyboard. But its frequency is so low that the human ear, unfortunately, can't hear it. But besides that, we can only hear something inside spaceships. These are small pockets of air after all. In a spacesuit, you'd hear sounds very well too, including your breathing or blood circulation in a spacesuit. But two astronauts flying side by side wouldn't hear each other, even if they got very close and shouted very loudly. It's quite funny. If you, being an astronaut, bumped into something, it would be very loud for you, but your friend wouldn't hear anything. That's why astronauts use radio devices.
291, cancel your call, 279 will handle.
Now, purely theoretically, if you could somehow crawl out of your spacesuit and survive, you'd be able to hear the chatter and noises going on inside the spaceship. But how? Look, we have some air inside the ship, and it transmits sound. It reaches the metal casing and gets through it. And then, if you leaned against the ship, preferably touching it with your elbow or knee, the sound would be transmitted to the brain directly through your bones, ignoring the ears. Yes, our bones conduct sound. That's how, for example, deaf people listen to music. It's called bone conduction. It's used in some headphones and other technologies. You can do a little experiment. Hold your fingers over your ears. Shut them properly so that you really don't hear much. Then try to touch a sound source. It can be anything vibrating, for example, a speaker playing music, with some part of your body where the bone is close to the skin. Now, watch the miracle happen. You can hear the sound not through your ears, but directly in your brain. But please, don't repeat this experiment in open space. Now, you've probably heard about things like the sounds of space, where you can listen, for example, to the sounds made by the sun or different planets. How do we record these ones? Easily. This is another way to hear sound in space: electromagnetic waves. In other words, a radio. Radio is the same form of electromagnetic radiation as light. These waves can travel in a vacuum without any problems. Astronauts' transmitters work that way. An astronaut says something to their friend. The sound waves turn into radio waves, reach the other person, and are then converted back to sounds. And this is how we get so-called space sounds. Our planet is actually very loud in that regard. We're sending a huge amount of radio waves into the universe, all radio signals we've ever listened to. It's a pity that they travel only 110 light years away from us. But you know, I think it's good we don't hear everything that happens in space. Imagine if sound could easily travel through the universe. We would hear everything, from solar flares to nearby supernovas. Horrifying, right? So maybe we're just lucky.
So here's the deal. Something is bound to happen that can affect everything we've ever known about space and time. You've heard of black holes, right? That denser-than-life type of phenomenon that usually exists in the center of galaxies. Two of them, located 9 billion light-years away from Earth, are expected to collapse into each other, and oh my, I do not want to be around to see that. Let's get one thing straight. Black holes are the most powerful things in the entire universe that we know of. If they decided to go all Revenge of the Sith on us, we'd be doomed. A black hole was once a massive star that went supernova, meaning that the star collapsed onto itself, and the sheer magnitude of the explosion created a black hole in its place. By the way, black holes do not pull things inside like a vacuum cleaner. That's just a popular myth. Say we were to replace our sun with a black hole at the center of the solar system. Not much would change, except that maybe we'd all freeze. But black holes can do something much worse than vacuum stuff. They can delete the universe itself. If a black hole was to follow a normal timeline, it would go from its creation to total disappearance. But this process is very, very slow. I'm talking billions and billions of years before a black hole loses its mass entirely. That happens because they are constantly losing their mass, every single second. Black holes radiate their mass away, like a boiling teapot loses its water as steam. Yet, things rarely go as planned, both in our lives and apparently in the universe itself. So it wouldn't be that much of a surprise to find out that 2 black holes are en route to collapse. That's what scientists have found out recently. And let's just say that this is one of the reasons why the scientific community is freaking out just a little bit. The first question that comes to mind is, what does that mean for us humans? Total annihilation? Now. No need to be this dramatic. The best case scenario, we'd be in for an interstellar type of experience. Roll me in, please. Let's rewind a little bit to understand how this would happen. 45 years ago, a group of scientists began noticing a weird behavior coming from a galaxy far, far away. The galaxy is found 9 billion light-years away, and its scientific name is a mouthful, SDSS J1430 Plo2303, but let's just call it Super Far Away Galaxy. You might be asking yourself, how did scientists observe this black hole so far away if it doesn't emit any light? Good question. That's because black holes gather disks of gas around them, and they emit some of this material into space. These jets can be detected from a distance of millions of light years. Now, if these hot gas jets are directed towards space, then scientists give these black holes a special name, blazars. A particular blazar has been gaining worldwide attention recently, the PKS 2131021, long name, but let's just call it Andy. Imagine you're a scientist at Caltech, and you're looking at a blazar in your radio telescope, and you notice its strange behavior. Its brightness goes on and off, like the ticking of a clock. At first, you don't understand what's happening over there in a distant corner of the galaxy, but then you realize that there must be another black hole circling the first one. In other words, scientists discovered that Andy was being orbited by another blazar, Gomer, and the regularity of their twinkling can only mean they are close to a total collapse. It gets worse. Each of the two blazars is estimated to be a few 100 million times the mass of our sun. Have you seen our sun? It's huge. It's already 333,000 times the mass of our Earth. This means we're destined to face something out of our league. This is not the first time scientists have detected something like this. In September 2015, the LIGO Observatory detected a collision of two black holes. Each of them was as heavy as 30 suns, and an equivalent of 3 solar masses was released once they crashed into each other. And guess what? This gravitational wave passed through Earth at the speed of light, but we weren't really affected by it. Maybe you were sleeping and felt something weird in the air, but nothing significant happened to us as a species or to our planet. But that's because the blast was weak. The thing is, the expected collision between Andy and Gomer will send unprecedented gravitational waves throughout galaxies. And they will reach the solar system. But what is this shockwave actually capable of doing? It could stop our sun from releasing gas for a few minutes, which means it would stop heating the solar system. So, let's say you were going about your summer day, and out of the blue, the atmosphere froze for a few seconds. Doesn't sound too nice, huh? But that's actually a better possibility than the next one. In one of the worst-case scenarios, the blast from the collision between Andy and Gomer could break bonds between atoms and make everything disintegrate. You, me, your cat. We'd all turn into tiny particles floating in the vacuum of space. This may sound scary, but scientists say that an atom is made out of 99% empty space. This means that everyone on this Earth, all 8 billion of us, and everything that exists, plants, objects, animals, are all made up of 99% empty space. So perhaps all that Andy and Gomer would do is separate all of our atoms and desolidify us. Then again, the blast could mess with the fabric of space and time as we know it. You remember Albert Einstein, right? Crazy hair? He's the name behind the theory of relativity. Einstein discovered that time is relative. It is always dependent on the observer. This would mean that time is not the same throughout the cosmos. Why though? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein discovered that gravity is the effect that objects have on the fabric of space-time. Every object that has a mass, including me, you, your cat, and our planet, creates a warp or distortion in the fabric of space-time that causes it to bend. The bigger the mass, the bigger the gravitational force, and the bigger the distortion on the fabric. It may sound complicated, but hey, this is what creates different perceptions of space and time throughout the cosmos. This is why you'll age differently on Earth and on Jupiter. This is why time passes completely differently for astronauts on long missions and for people that remain on Earth. And this is why a collision of two megablazars could mess with our perceptions of space and time, due to the sheer force of its gravitational shockwaves. Got it? Not to mention that black holes are already a huge warp in the fabric of space-time. You remember that interstellar scene, right? Where the lead character bends the space-time continuum through a black hole. Don't try this at home though. As far as we know, anyone who chooses to go inside a black hole has no guarantee of making it home again. Scientists say that this blazer explosion will happen in approximately 10,000 years. But wait a minute, if this blazer lies 9 billion light years away from Earth, it means that these two black holes should have already collided long before our solar system and home planet were born. You see, the solar system was born just around 4 billion years ago, and since it takes us 9 billion light years to receive the light emitted from the blazers in the first place, this means that the collapse of the two blazars already took place, and that it will reach Earth 10,000 years from now. This means the shockwaves are already making their way through the galaxies at this very moment. But still, it's something not even your great-great-great-great-great-grandchildren will be around to see.
An object weighing billions of times the mass of our sun must be easy to find, right? Wrong. Unfortunately, it might not be that simple, like in the case with a missing black hole. But let's travel to the galaxy cluster Able 2261, hosting a supermassive black hole at its center. Or at least, that's where it's supposed to be. The main problem is this giant space phenomenon is nowhere to be found. Now, supermassive black holes are mega monsters, churning slowly at the centers of their home galaxies. They gather tremendous clouds of gas and dust around them, which makes them swell up to sizes the human mind can't begin to imagine. If a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved even a bit closer to our solar system, we'd be doomed. The distance between this huge thing and Earth could be several dozens of light years, and still, it would wreak havoc on our planet. Earth, along with other things making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity or longer. Hey, who knows, right? So it's good that such black holes stay away from us at the moment. So, let's see what's happened with that runaway supermassive black hole from that gigantic cluster of galaxies around 2.7 billion years away from our planet. Scientists have been looking for it with the help of NASA's Chandra X-ray Observatory and Hubble Space Telescope, but so far, no result. The main problem with finding a black hole is that it's, black, and space is, you guessed it, black too. So there's no contrast whatsoever that could help astronomers spot the hole, but scientists haven't given up yet. After all, they have a lot of other technologies to find black holes, small and big, in the vastness of space. Some of these methods involve watching the stars orbiting black holes. Sometimes it's a faint gravitational wave signal, which is produced when two black holes collide, but the most reliable technique is watching dust and gas falling to their doom. The thing is, black holes are space objects with insane gravity, so regions of space surrounding them are usually a bit chaotic, gas and dust getting pulled into the bottomless abyss, compressing and heating up. In the process, it releases a flood of X-ray radiation, so astronomers look for extremely bright X-ray sources in the universe. Chances are, those are the last gasps of giant clumps of material before they disappear into a black hole. Then why can't scientists find such X-ray signatures left by the black hole in Able 2261? One of the most mysterious things about its disappearance is that radio telescopes have spotted some signs of massive plumes of superheated material, launched at one point within the last 50 million years. These plumes were most likely caused by a large black hole, which is nowhere to be found these days. So, at the moment, we can only play a guessing game. Maybe two medium-sized black holes collided, pushing the newly merged giant out of the center of the galaxy. The observations of the stars in that galaxy have shown a clump of dense material a few thousand light years away from the galaxy's core. Maybe it's the runaway black hole, but disappointingly, no X-ray signals are coming from that clump. Or the hole might still be there, in its rightful place, but it's, slumbering. If it doesn't get a fresh supply of gas and dust, it has nothing to feed on. As a result, it can't release a flood of X-rays. But again, the answer, do not disturb, the black hole is sleeping now, isn't very satisfying. Why isn't it getting its space food? What happened 50 million years ago? What is that clump of material speeding away from the galaxy center? So many questions and no answers so far. At least we know what black holes look like. Well, kinda. It's actually the shadow of a black hole's event horizon visible against the glowing superheated material falling inside the hole. The first ever mugshot of a black hole appeared in 2019, but the data for its creation was collected in 2017. It took an international team consisting of more than 200 astronomers 2 years to assemble the image. We can admire this amazing space phenomenon thanks to a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Why such a name? The thing is that the event horizon is a point of no return on the outskirts of a black hole. Once something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape the black hole's clutches. Anyway, to capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 powerful radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, to keep the chances of rain and bad weather to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. On each observation day, the telescope gathers roughly 350 terabytes of data. That's 10 times the amount of data collected every day at the Large Hadron Collider. But let's speak more about black holes themselves. There are stellar black holes, smaller but even more dangerous than their supermassive peers. They appear when stars that have run out of their star food fall into themselves. If a star used to be big enough, it keeps compressing and compressing some more, and voila, a baby stellar black hole is born. But even if I call such a hole a small one, it's still 5 to several tens of times heavier than the sun. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 SUVs. One theory claims tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. There is a supermassive black hole smack dab in the middle of our galaxy, the Milky Way. Its name is Sagittarius A, and it's 4.3 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light years away from Earth, too far to have any influence on our planet. By the way, recently, astronomers have discovered that this supermassive black hole might be leaking. If it's true, it probably means that Sagittarius A isn't a sleeping giant. As previously thought, it might still be active, and the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Maybe we should burp this baby? If you ever find yourself near a black hole, get ready that the time will significantly slow down. It may work for you if you aren't eager to grow older. Just don't let yourself be tugged behind the point of no return. Another danger of hanging around a black hole is that it might start behaving like a massive galactic volcano. From time to time, black holes flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Okay, mind blown. I'm out of here. Imagine a black hole, a terrifyingly dense space object, pulling inside everything that comes too close. Nothing can escape its clutches, even a beam of light. And now, imagine two of these space monsters colliding. Scary? You bet! Astronomers have spotted two supermassive black holes feasting on the cosmic material of two merging galaxies in distant space. This phenomenon is the closest to colliding black holes we have ever seen. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times larger than of our suns. And two such giants have been recently spotted with the help of an array of telescopes in northern Chile's Atacama Desert, the Atacama Large Millimeter Submillimeter Array of Telescopes, ALMA. Astronomers originally used these telescopes to watch two merging galaxies located approximately 500 million light-years away from Earth. Thanks to being alert at all times, scientists have also noticed that two gigantic black holes were growing alongside each other. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, only 125 million times larger. We can't see black holes directly. If you were to travel to a black hole, you wouldn't notice it until it was too late. The only detail that would give away the approaching black hole would be a slight blurring of distant stars due to the hole's gravitational lensing effect. The two black holes we are talking about are no different. They aren't visible directly, but are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light, and have come to the conclusion that they are unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which, astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. The thing is, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA, Atacama Large Millimeter Submillimeter Array of Telescopes, helped astronomers observe those bright and compact regions where matter swirls around the black holes. Imagine how surprised astronomers were when, instead of one black hole, they discovered two of them, munching on the dust and gas stirred up by the massive space merger. Galaxy mergers are way more common in the distant universe than in our neighborhood, and this discovery may mean that such black hole binaries are likely to be much more common than we previously thought too. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes there are that are about to collide in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in around 4.5 billion years. By the way, the first photo of a black hole was taken in 2019. An international team of scientists consisting of more than 200 astronomers had been working for years to get this result. And their efforts finally paid off. The object in the photo is about 55 light-years away from Earth, at the center of the galaxy M87. You can now admire this amazing space phenomenon thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. The event horizon is a point of no return on the outskirts of a black hole. Once something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape. To capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, they were constantly monitoring the amount of moisture in the air, since too much humidity would ruin the images. To keep the chances of rain to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. All in all, the process resembled a carefully coordinated dance. But thanks to these preparations, in over 2 weeks, the telescopes collected 5,000 trillion bytes of data. It was then processed by several supercomputers, and scientists finally got the long-awaited images. And what they observed was a monster of a black hole measuring about 25 billion miles across. Now, how about we talk about the coolest black hole facts? There are baby black holes called primordial, and they are really tiny. They vary from the size of an atom to that of a mountain. There is a theory that galaxies get formed around black holes. This means that when a large star explodes, a black hole appears in its place, and then the rest of the galaxy just forms around it. There is a supermassive black hole right in the middle of the Milky Way galaxy. Its name is Sagittarius A, pronounced A star, and it's 4 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light years away from Earth. That's too far for this monster to have any influence on our planet. Besides Sagittarius A, there are 100 million medium-sized black holes in our galaxy. And can you imagine how many black holes in total there are in all 100 billion galaxies that exist out there? You do the math. If you ever find yourself near a black hole, be ready that time will slow down significantly. It may work for you if you aren't so eager to grow older. Just don't let yourself be tugged into the event horizon. Whoops, bye-bye. Black holes aren't some hungry predators that roam the universe preying on poor, unsuspecting planets. They just gulp down the stuff that ends up too close to them. On top of that, they sometimes fling out spitballs the size of a planet. How does this matter escape the pull of black holes? Typically, it manages to slip away before going past the point of no return. In fact, with Sagittarius A, we should be worried not about its gravitational pull, but about the very spitballs. After all, the monster black hole hurls them in the direction of Earth at a speed of 20 million miles per hour. What if, one day, one of them reaches our planet? If you manage to squeeze Earth to the size of a cherry tomato, it would turn into a black hole. In fact, you could also become one if you agreed to be scaled down to an atom. South African astronomers have recently come across another head-scratching black hole mystery. In a region of distant space, they noticed that several black holes located in different galaxies aligned in the same direction. It looks as if their gas emissions have been synchronized by design. Nowadays, scientists can't explain why and how black holes, which are about 300 million light years away from one another, can be acting in unison. It's a puzzlement. Imagine a world of seething hot metal, where iron and nickel dance in a fiery inferno. This is the inner core, the heart of our planet. But what if this very heart was changing? The latest research suggests that the Earth's inner core may be slowing down and even reversing its rotation. Is this a sign of the end times? Will the Earth come crashing down on itself? Let's find out. Imagine you have a giant onion and every layer represents a different layer of the Earth. The center of this onion, the part you can never reach, represents Earth's inner core. It's like a mysterious land that no one has ever set foot on, yet scientists have been trying to uncover its secrets for centuries. Imagine diving deep into the center of the Earth, beyond the crust, the mantle, and finally, 2,897 kilometers below the surface, where you'd reach the inner core. It's a ball of seething hot metal, made up of solid iron and nickel, and it's so hot it glows a brilliant white. It's also surrounded by a liquid outer core. This mysterious place is unlike anything else on our planet, and get this, it's spinning on its own axis. The inner core is like a fire tornado that's constantly swirling, generating heat and energy from the inside out. But why is it so important to study this little piece of the Earth? Well, it's responsible for creating our magnetic field. This magnetic field is important to study because it protects us from harmful radiation from the sun. It's created by the movement of molten metal in the Earth's outer core and the spinning of the Earth. These movements generate electrical currents, which then create the magnetic field. It's like a shield that protects us and helps keep our planet healthy and safe. But there's still so much we don't know about the inner core. For example, how did it form? Scientists believe it started to solidify about 1 billion years ago, but why did this happen? What was the trigger? Or for example, what about the inner core's crystal structure? It's thought to be a type of iron called hexagonal close-packed iron, but we still don't know if it's actually the case. In other words, we have many theories, but unfortunately, there's no way to confirm them, at least for now. So, how do scientists study the inner core if no one can go there? They use seismology. Seismology is like a sonic scanner for the Earth. You send sound waves through the Earth and measure how they bounce back to see what's inside. That's basically how we discovered the inner core way back in the 1930s. Imagine you're listening to the sound waves with your special seismology machine. Suddenly, you hear a strange sound, like a ping. It's different from the other sounds you've been hearing, and you can't explain why. You keep listening, and you hear the ping again and again. You start to realize that this ping is happening every time the sound wave hits the Earth's center. You study the data more and more, and finally, you figure it out. The Earth has a solid inner core. This discovery was a big breakthrough and helped us better understand what's inside our planet and how it works. Right now, scientists also use something like this to study what's inside our planet. When earthquakes occur, waves travel through the Earth and bounce off different layers, including the inner core. By studying these waves, scientists can learn about the inner core's properties, such as its density and temperature. They're basically solving a mystery by piecing together tiny clues, and every new discovery brings us one step closer to understanding it. The inner core is a unique and fascinating part of our planet. It's a place where the laws of physics work in different ways than they do on the surface, and it's a place where scientists are still trying to unravel its many mysteries. And here's one of them. For some reason, the heart of our planet is about to stop spinning. A new study about this was published in Nature Geoscience. It was made by the researchers at Peking University in China. It has revealed a huge twist. The scientists found that the inner core's spin rate has slowed down significantly. It's something that no one expected, but according to the results of their study, the slowing down began all the way back in 2009. And that's not all. Their results also suggest that the inner core may be reversing its rotation. That's right, this hot ball of iron and nickel that has been spinning around for millions of years may be slowing down and changing direction. It's like when a spinning top starts to slow down, except this is happening in the center of our planet. Scientists have been puzzled over this discovery for quite some time now. So, what does it all mean, and why is this happening? Well, it turns out that there might be a larger pattern at play. The scientists believe that this change in the inner core's rotation may be due to the influence of Earth's mantle and the magnetic field of Earth's outer core. The mantle and the outer core are affecting the inner core, which is causing its spinning rate to slow down and potentially change direction. Before this study, scientists thought that the inner core was spinning faster than the Earth's crust. However, this new information suggests that the inner core may be slowing down due to the gravitational effect of the Earth's mantle and the magnetic field of its outer core. But here's where it gets even more interesting. When researchers took a closer look at data stretching all the way back to the 1960s, they discovered that the rotation of Earth's inner core was consistent from the late 1970s to the early 2000s. Before that, they found that another possible slowing down or reversal event may have occurred in the early 1970s. It's like the inner core's spin is like a roller coaster ride, speeding up, slowing down, and possibly reversing course over a period of time. The researchers estimate that these switches occur every 7 decades or so, which is pretty wild. But why is it happening? Unfortunately, We still have no idea. The exact reasons for why the Earth's inner core sometimes stops and starts spinning in another direction aren't yet well understood. However, scientists believe that it may be due to complex interactions between the solid inner core and the surrounding molten outer core. A lot of different things can be at play here: the changes in the temperature, pressure, and composition of the core, as well as the movement of material within the core itself, and so on. Also, as we said before, the Earth's magnetic field and the gravitational forces from the surrounding mantle might also play a role here. We need further research to fully understand the mechanisms behind the inner core's rotation changes. So, is the world ending? Fortunately, no, not just yet. While the inner core is changing direction right now, it's not the end of the world as we know it, and even though findings may seem like a huge deal, life on Earth's surface hasn't been impacted much, if at all. In fact, it's just a fascinating part of the Earth's inner workings that we're learning more about every day. So you can say with a relief, nothing cataclysmic is happening. Moreover, according to Hrvoje Tkalčić, a geophysicist at Australian National University, the inner core is now more in sync with the rest of the planet than a decade ago, when it was spinning a bit faster. All in all, this new study has added a strange twist to the story of Earth's inner core, and scientists believe that there's still much more to discover about this mysterious place. Who knows what other secrets lie hidden in the heart of our planet? The possibilities are endless. So, let's keep researching and enjoy our time on this amazing planet. Attention! Attention! Something very exciting is going on Saturn. It's called a spoke season. And no, the planet isn't turning into a giant gaseous wheel. Let me tell you more about this phenomenon. Each year, NASA's Hubble Space Telescope devotes some of its time to observing Saturn, a gas giant, like me, the second largest planet in the solar system. And this space body always has something new to surprise us with. For example, look at one of the latest images of the gas giant. See those smudgy spokes? They mean that Saturn's spoke season is starting. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. Keep this in mind. It's important. Now, the next thing we need to talk about to understand the concept of the unique spoke season on Saturn is the equinox. On Earth, it's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Saturn, it's something a bit different. An equinox occurs when Saturn's rings are titled edge-on to the sun. And even though equinoxes on Saturn happen every spring and fall, just like on our planet, they actually occur very seldom, roughly once in 15 Earth years. That's why astronomers are so excited about this event. Now look, there are 2 smudgy spokes in this ring. It's called Ring B, on the left of the picture. They resemble the spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light. It depends on the angle and illumination. Sometimes they might look like blobs, rather than something with a classic radial spoke shape. They also don't last long, but more and more will start to appear the closer we're to May 6, 2025. That's when the autumnal equinox on Saturn will occur. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. On Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too, and it probably temporarily levitates these particles above the larger boulders the rings consist of. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. At that time, NASA's Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It quickly proved that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. That mission was finished in 2017. Now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon. Because even though other gas giants in the solar system also have rings, those are not so visible, and scientists don't know whether spokes occur on those planets. But these spokes aren't the only exciting space phenomenon. Our solar system is a fascinating place. That's why. If you were standing at the Martian equator barefoot, your feet wouldn't get cold. The temperature there would feel like on a sunny spring day, but you would have to wear a hat. At the height of your head, it would be freezing cold. Venus spins backward compared to most other planets in the solar system and the sun itself. One of the explanations astronomers have come up with is a collision with some solid object. For example, an asteroid that happened in the past. Jupiter's moon Io has hundreds of volcanoes, which makes the satellite the most volcanically active object in the solar system. The moon also has a weird yellowish surface. It looks blotted and resembles a pepperoni pizza. Europa, one of Jupiter's 4 biggest moons, is covered with ice. This ice shell can be 16 to 24 kilometers thick. It also has some smooth patches. So, if you're into ice skating, you would like it there. If you lump together all the known asteroids in the solar system, their total weight would still be smaller than 10% of the mass of our moon. Scientists believe that Mercury might still have a partially molten core. It could explain why Mercury has a magnetic field, even if it's just 1% as strong as Earth's. Mercury's core takes up around 42% of the planet's volume. Mercury also has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. These wrinkles are called lobate scarps. The biggest of these scarps can be hundreds of miles long and up to a mile high. Uranus is the only planet in the solar system to rotate on its side. The reason might be an ancient mega-powerful collision with an Earth-sized object, but so far it's just a theory. Mars might get a set of rings of its own in the next 70 million years. Its largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. I won't be around then, so I'll just take their word for it. Scientists think that the moon's surface has more craters than Earth's because it doesn't have so much natural activity going on. Winds, rains, earthquakes, and erosion keep altering the surface of our planet, but the moon has almost no weather to change its appearance. Saturn is the most flattened planet in the solar system. It's squished at the poles, and any point on the equator is about 6,400 kilometers further from the center of the planet than the poles. The Hubble Space Telescope weighs almost as much as 2 male African elephants and is as long as a big school bus. Yeah, that's a launch I'd love to see. 2 elephants in a school bus. It's made almost 1.5 million observations since it was launched in 1990. Astronomers have used this data to write about 15,000 scientific papers. Everything on Earth and everything people can see in space with the help of telescopes is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 68% of the universe is dark energy, and the remaining 27% is dark matter. Does that really matter? As a matter of fact, it does. Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm, measuring almost 8,000 kilometers across. That's 2/3 the diameter of Earth. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. Saturn is also the only planet in the solar system that's less dense than water. In other words, if you found a bathtub huge enough to fit this gas giant, it would float there like a rubber duck. Earthquakes on the moon don't occur as often as on our planet, but when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. One of Saturn's moons, Iapetus, has bizarre two-tone coloring. The difference between the moon's two hemispheres is great. One of them is light, and the other is eerily dark. Scientists haven't figured out this mystery yet. The only asteroid belt in the solar system astronomers know about is between Mars and Jupiter. There are thousands of asteroids in this area. They're irregularly shaped solid objects of different sizes, but all of them are way smaller than a planet. Scientists have analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. Some of the rocks turned out to have a Martian origin. Others arrived from the moon or the asteroid belt between Mars and Jupiter. Oh, space rocks. So we can also say space rocks. Yeah, we could say that. Do you know what the third brightest object in the night sky is? If you said the International Space Station, you're absolutely right. And the coolest thing? You can sign up for a special service, and you'll get a text every time the ISS is traveling over your location. And if it happens at night, you can see it with the unaided eye. But be quick, because the station is very fast. It moves at a speed of 5 miles per second and circles our planet every 90 minutes. If you moved at such speed, you'd be able to make a round trip to the moon within a day. At the same time, the ISS isn't the fastest human-built object. This title belongs to the Parker Solar Probe that travels around Venus and the Sun at a speed of 430,000 miles per hour. On the bright side, astronauts on the ISS see a sunrise and sunset 16 times every 24 hours. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 357 ft long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view bay window. And now, let's imagine what your life would be like if you were an astronaut on the International Space Station. For one thing, you'd be able to do some cool things there, like throwing boomerangs. Once, one astronaut threw a boomerang inside the International Space Station, and it returned to him. So just remember that as long as there is some air, even weightlessness won't stop you from having a bit of fun. On the ISS, you would never have to deal with disgusting smells. There is a specially trained person who smells everything astronauts take with them to space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kind of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 1 pound of load to the International Space Station costs more than $10,000. That's why it costs less to throw your clothes away when they get dirty than to waste water on washing them. While sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head, and you'd get oxygen deprived. But what would you do on the ISS? Most likely, it would be space-related research. Astronauts on the station not only explore the possibility of future space travel, but also conduct all kinds of studies and explore the effect of microgravity on the human body. Oh, and speaking of microgravity, people often think that in space, you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the moon can orbit Earth, and the sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged, but microgravity, which means very small gravity. Earth's gravity on the space station is only around 10 or 12% weaker than the gravity on the planet's surface. But astronauts are constantly in free fall. The spacecraft, people inside, and all the objects aboard keep falling forward. Not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they're very different things. Anyway, on your way to the ISS, you'd be wearing a bright orange spacesuit. Its color is called International Orange, and it has the same shade as the paint that coats Tokyo Tower in Japan or Golden Gate Bridge in San Francisco. But once you reach the vast expanse of space, you'd swap orange for Snow White. The thing is, the orange suit is equipped with the stuff that can help astronauts survive if something goes wrong during the launch or landing of the spaceship. For example, a regular pumpkin suit has flares, medications, survival gear, a radio, and a parachute. As for the white, bulky spacesuits, those are EVA, which stands for Extravehicular Activities, suits. Their purpose is totally different from that of the orange suits. Astronauts put on EVA suits when going on a spacewalk. Such an outfit can protect them from the unfriendly conditions of outer space, with its extreme temperatures and the near vacuum. Besides, the white suit can prevent small debris from hurting space travelers. By the way, if you needed to scratch your nose while wearing your EVA suit, you would use a patch of Velcro inside the helmet. The lack of gravity also makes sneezing inside a spacesuit a serious problem. If you absolutely had to sneeze while on a spacewalk, you'd have to bend your head downward and sneeze into your chest. Otherwise, your visor would have to be equipped with tiny windshield wipers. In space, you'd often see random flashes of light, and those wouldn't be hallucinations. Cosmic rays hitting your optic nerve would create such an effect. You don't see similar flashes here on Earth because the magnetosphere doesn't let cosmic rays reach you. Before going to space, you'd have some underwater training. It's supposed to simulate zero gravity, but in fact, it has nothing in common with being in outer space. So the main purpose of this training is to see how future astronauts can deal with extreme environments. Oh, and later, during space adaptation, you might feel, let's say, weird. Around 50 to 75% of astronauts have highly unpleasant symptoms, such as vertigo, headaches, nausea, and overall tiredness. Luckily, everything usually gets back to normal within 72 hours. Before you were chosen to fly to space, you'd have to get through incredibly tough competition. According to NASA, they accept only 8 applicants out of 6,000. On top of that, the selection process takes around 18 months. If you felt homesick on a mission and started crying, your tears wouldn't flow down your face. Instead, they'd gather into thick blobs of liquid around your eyes because the water surface tension would hold your tears together. You'd have to remember to attach yourself to something before falling asleep. Otherwise, you'd easily float away from the spot where you went to bed and bump into a hard surface. That's why astronauts usually rest in sleeping bags in a small crew cabin. Another issue you'd have to deal with would be taking a shower in microgravity conditions, and it isn't an easy feat. Astronauts take a shower in an enclosed cylinder, which keeps water from floating away. They use a no-rinse shampoo, spray themselves with water to rinse off the soap, and finally, use a vacuum hose that pulls inside all the water left on their body. You'd have to get used to a dramatic change in your diet. You'd have 3 meals a day. Nothing outstanding here. But instead of sitting down to enjoy your lunch, you'd float around. Your meal would consist of some dehydrated and canned food items, and it might take a lot of time to finish it since you'd have to be very careful not to let your food get away in the process. Now imagine needing a haircut. After all, you'd spend no less than half a year on the ISS. To change your image, you'd have to use special clippers with a vacuum attached to them. It's the year 2031, and the first human has just set foot on the red surface of Mars. It was a long flight that lasted 172 days. It was a tough journey. There were lots of technical issues. There were some physiological obstacles. Astronauts had to deliver tons of equipment and energy-generating and life-supporting systems to the red planet. Those responsible for the mission had to understand how to deal with low-pressure atmosphere and catastrophic sandstorms. how to keep people safe on Mars' surface, and how to bring them back to Earth after their work is done. It does sound like a science fiction story, but soon it's going to be our reality. But the coolest thing? It's not the limit. After exploring Mars, people might set even more ambitious goals, and this is what some of them may look like. The next planet to visit could be Venus, but it would be a challenging task. Venus is also called the morning or evening star, all because it shines so brightly in Earth's sky that it's the first one to appear after sunset and the last one to vanish after sunrise. But in terms of exploration, Venus is very unfriendly to humans. Its atmospheric pressure is about 92 times as great as the pressure on Earth. And the temperatures on its surface are, on average, 850 ZOF. Modern technologies wouldn't allow us to build an infrastructure that would allow people to survive on the planet for longer than a couple of minutes. But then, why would we set sail for Venus? Here's a curious thing. At the height of 30 to 40 miles above the surface of the planet, there are the most Earth-like conditions in the entire solar system. The pressure there is almost the same as in the mountains on Earth, and the temperatures range from 70 to 85 AF. If the planet's atmosphere was made up of oxygen and not toxic gases, we could live there without any additional equipment. Or we could go to Phobos and Deimos. Those are Mars's moons. It would be the first time humans set foot on the moon of some other planet. Phobos is located a mere 3,700 miles away from the surface of the red planet. It would take no longer than a day to reach it. This potato-shaped piece of rock is quite small, a mere 13 miles across. This is the reason why it has very weak gravity. Deimos is a bit farther away from Mars, about 15,000 miles. But this mini-moon is even smaller than Phobos. It's a bit more than 7 miles across. In other words, visiting these moons wouldn't be unlike landing on an asteroid. And the greatest challenge astronauts would face would be leaving the surface of Mars. To do it, they would need loads of fuel. So, most likely, the first trips to Phobos and Deimos would be launched from space stations orbiting Mars. We could set an even more ambitious goal and head for Jupiter and its moons. The distance between this gas giant and our home planet is 365 to 600 million miles. This distance can be so different because the planets follow their elliptical orbits around the Sun, getting closer then farther apart. The minimal distance occurs every 13 months. If people set off on this long journey during this period of time, it would still take them about 2 years to get there. Since Jupiter is mostly gas, on-planet exploration wouldn't be possible. We could probably fly around the largest planet in the solar system and even dive into its atmosphere. But much more interesting for exploration objects would be Jupiter's moons. Let's say Europa. This natural satellite has a water ice crust. It can be from 10 to 15 miles thick. Under this crust, there might be liquid water. The core of the moon might consist of liquid metal inside a rocky shell. Its super thin atmosphere contains some oxygen. Considering all this, it would be a rather comfortable place for people to explore, if not for its temperature. It doesn't rise above 240 HF. We could visit another Jupiter's moon that is called Ganymede. It's an ice satellite with a very thin atmosphere that contains oxygen, or Callisto. It's the second largest among Jupiter's moons. Its icy crust is about 124 miles thick, and it's very cold on the moon, around 200 to 1 F. People could also send an expedition to Saturn and its moons, for example, Titan or Rhea. The gas giant itself is twice as far away from Earth as Jupiter. It means it would take astronauts more than 3 years to get to this planet. But if the spaceship was launched from a space station on Mars, it could reduce the travel time by 25 to 50%. But even if the starting point of this expedition was Earth, with advanced technologies like nuclear thermal propulsion, such a journey could take just a year or even less. Saturn can't be explored directly, so researchers would probably start with its largest moon, Titan. It's also the second largest moon in the solar system. This natural satellite has an atmosphere that mostly consists of nitrogen. The pressure on its surface is twice higher than that on Earth. There are winds and rain on Titan, lakes and rivers, but those consist of liquid ethane and methane rather than water. It's actually a good thing. We'd have a lot of resources to produce fuel and energy. Rhea is the second largest of Saturn's moons. It's made up mostly of water ice. Its atmosphere is super thin, but it also has some oxygen in it. Actually, all the largest moons of Saturn have only one serious drawback: it's freezing cold there. On the bright side, they all have plenty of resources to produce energy and other life-sustaining elements. And it would be much easier and faster than the same process on Mars. But what if we could explore exoplanets? Those are planets that travel outside our solar system. If we manage to get so far away from Earth, maybe we would reach some potentially habitable worlds. It could be Proxima Centauri b. It's the closest to Earth exoplanet, and recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. It means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star, so the radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. It would take way longer to reach potentially habitable Gliese 832c. This exoplanet is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. Gliese 832c is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this parent star is a red dwarf, it's much cooler and dimmer than the Sun. So, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that, unfortunately, Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth.